Thank you, everybody, for joining. Let's jump right into it. Last fall, we ran a study and we looked at 10,000 publicly exposed keys on GitHub. On the very first day, they were notified that a key that they put out there committed leaked. And we tracked for the next 30 days every single key to see if or when that key would be revoked. And as you can see here on this trend, on the y-axis, we have days since the key was leaked. And on the, on the x-axis, on the y-axis, we have the percentage of keys that were still valid. And around day 7, the number drops off in terms of the amount of revocation going on. So we're about like 80% of keys were still not revoked by day 7. And then it kind of plateaued down around 74%. And that left us with the statistic that 74% of exposed keys on GitHub stayed live after 30 days. That's a startlingly live and huge amount of keys that were still valid. And we thought about it and we we're wondering, like, why? Why is that number so high? Why are so many keys still live after being exposed? And there's a lot of reasons, but one of them centers around the fact that security teams find it difficult to determine the risk associated with the specific leaked API key. Now, what do I mean? Let's take a look at this string. I'm going to assume nobody watching knows inherently what this API key is, what type it is. It's actually an octa key. The 00 prefix gives it away, but there's no way you'd know that unless you're really diving deep into API key documentation. But if that's all you have, if you just have this API key and a little bit of code near it, how do you determine the risk associated with that key leaking? How do you prioritize remediating this key over some other key, say over an AWS key or a GitHub key or something else? You really need more information. You may know that Okta is a critical service used by your company, but do you know the risk that that particular API key represents? And so in general, if we take a step back, like what information do we need to know to understand the risk associated with a leaked key? In general, there's 3 questions that we figured out that we probably should know. The first seems super obvious. Whose key is it? Right? It's so obvious you might even skip over it. But the reality is figuring out whose key it is isn't always straightforward. Now, I imagine some of you are thinking like, well, if it's a leaked key in a code repository, you probably could see who committed it. In this case, in this example, Dylan committed this fake GitHub token. Unfortunately, it's not always that straightforward. Take a look at this image. This is the classic Alice and Bob scenario. Bob is the developer, like Dylan, that leaked the key on GitHub. But in many cases, Alice is actually the key creator or owner, and Alice shares the key with Bob. So if somebody's reaching out to Bob to say, hey, Bob, you leaked this key, Bob might not remember Alice gave him the key. Bob can't access the portal to figure out what the permissions are for the key. It's all on Alice. And if Alice leaves the company, it makes that challenge even more difficult. And this isn't just some contrived example. It's very common for developers to share .env files, to use common secrets vaults when injecting secrets into local development environments, accidentally committing them to code repositories. This happens all the time, and it happens a lot more than I even expected. So the first question truly is, whose key is it? But the second is, what permissions does the key have? It sounds kind of obvious. It does get a little more complicated, though. And the third question is, what can the key access? So let me explain a little bit about the difference between the second and the third question. The second is talking about permissions. We're talking about read, write only, admin access, maybe can access the billing component of an API key or an account that the API key can access. The second or third question, rather, is resources. That's more talking about what objects can that key access. So thinking about like on GitHub, it'd be repositories, which specific repositories are accessible. With these 3 questions answered, security teams can better respond and understand which keys to prioritize, how to remediate keys, and actually start that process. But unfortunately, getting this data, just answering these questions, isn't always super trivial. And I want to share an actual example that relates to Okta. So going back to the Okta key. So it was a few months ago, I was scanning public GitHub repos with TruffleHog. And I found this exact, so this is the real screenshot of a valid Okta API key from a major tech company sitting in a public repo. And for those of you that know Okta, you might see here on line 24, it says Okta Preview, which is a testing environment. That will come up in a second, but suffice to say, it was a valid live Okta API key that had been sitting there for about a year. So I reported this through BugCrowd, They got back to me and they said, this is just a test environment. There's no security risk or impact, but here's $50 to not bother us about it. So that's understandable. Um, and this is what my best guess is to what happened behind the scenes. Somebody sent the developer that leaked it an email like this. It says, hey, you made a mistake a year ago. Can you tell me how bad that mistake was, basically, right? How sensitive is this key? Do we need to remediate it, etc.? And the developer, being a human, probably responded with something like, nah, it's not a big deal. Just a test key, can't really access anything. Don't worry about it. And so probably what happened after that is the security engineer at this company replied to them, thanks, and then replied to me, there's no security risk. We don't even need to revoke it, etc. Now that's one way it could go, and that's the way it played out. But there's a second way. If the security engineer dug in a little bit, knew something about Okta, they know that you could sync your preview environments with production. And potentially there could be production data in this testing environment. And so a more, gung-ho security analyst might have said, hey, please log into your account, screenshot the permissions for that key, provide evidence that there's no production data in that environment and that there hasn't been the entire year so that in case somebody else accessed it in that time, they wouldn't have accessed production data. But that requires the security engineer to be able to access that data, which the developer might not be willing to access, might not be able to access anymore. It also requires the security engineer to, or responder, the triager, to understand what questions to ask. That's a lot. That's a lot to ask for somebody that maybe isn't an expert on Okta. Now multiply that by all these different key types that could come in and that are leaked across an organization. Do this for AWS. AWS is extremely complicated. Um, GitHub is even complicated. Stripe, GitLab. You have to do this across all these different services. Just figuring out those three questions of whose key is it, what can it access, and with what permissions is incredibly difficult. And so then we go back to this string, this just literally a string of characters that is an API key. And at the moment, it's kind of like the security analyst, the triager just has to believe whoever they ask what the risk is. Um, and that's tough. And the general challenge here is around information. We just don't have enough information to properly remediate leak secrets. Um, And I think that can be further distilled down to two separate points. One is when we talk about APIs, there is no global standard for returning ownership, resources, and permission information from an API. So for example, it would be incredible to have like a slash owner or user, a slash resources, and a slash permissions endpoint, or maybe it's just one that returns all of that data. Anybody that needs to respond to this type of incident or look into the permissions associated with the key and resources could easily query for that data. There's no standard for that. Some SaaS providers and cloud providers give you endpoints, a couple that kind of get at that data, but it's all different and it's not uniform, and the vast majority don't. The other challenge is API keys rarely give access to the provider's GUI, meaning that SaaS provider's GUI. So you can't take an API key, log into Stripe, and look at all of what, in this case, a GitHub token could access, what repositories, what permissions. It's just not possible. And so now we have the situation where, you know, engineers, analysts don't have enough data to respond to leak secrets. And that's why we created TruffleHog Analyze and this methodology called self-discovery, which is in the title of this presentation, I'll get to in a second. But here's a little preview of TruffleHog Analyze. The idea is you provide a secret and we are self-discovering all of the permissions, objects that are accessible, and ownership data of the key so that without having to log in, let's say in this case to GitHub, you could still surface that data and understand what priority to place on that key, whose key is it, etc. But let's look a little broader, and then we'll go back to TruffleHog Analyze. So self-discovery, I mentioned this in the title of the presentation. The idea here is we are going to use existing documented or undocumented API endpoints to enumerate ownership, permission, and resource data about a key, literally just using the key. Sounds simple on the surface, but it gets really complicated. So I'm going to dig into each of the questions that we're trying to answer, provide a few examples, and then we'll go back to TruffleHog Analyze. So who owns the key? Simple, right? With GitHub, sure. There's a user endpoint. We query for it. We know their email address and name. Done. Then it gets harder. Mailgun is a good example. Mailgun has a /keys endpoint, and it returns all of the keys associated with the account. Well, that's great, but there's no way for us to say the key that I'm requesting is associated with this particular key ID. So even though it provides who created the key requester on the right side in the JSON, we don't know. Imagine like a list of items of like 10 of these keys. We don't know which key we're calling from. So it's hard for us to know exactly who created it. We could have a set of potential folks that created the key, but we don't know exactly which actually created it. So it gets us there kind of, but not fully. And there's a lot of situations like this. It's not always super straightforward. Let's talk about permissions. Before we dig too deep into how do we get permissions, I wanted to cover broadly the types of API keys that we're seeing. In general, I would say there are keys that are full access that give you, as you can imagine, access to every endpoint that the API provides, and then restricted access, meaning it's scoped down. It only provides a subset of those. This is how OpenAI works. If you generated an API key for a GPT, on the left is the restricted key type where it's, you either give read permissions for this type, right there, read or write. On the right side, you give all permissions. So that would be like the full access key. And those are pretty straightforward. It's pretty common. Open Weather is another API type. They have only one key type and it's full access. If you create an API key, it can access all of the API endpoints. But it does get a little more complicated. And I want to show you two quick examples and then I'll explain why all of this is relevant. SendGrid. SendGrid is email marketing automation. There are three key types: full access, restricted access, kind of like we've been talking about. But then there's this billing access. And the nuance here is full access and restricted access fundamentally don't get access to billing. So there's like this third type, but full access is even a misnomer because it can't access billing. So we're digging through the documentation a little bit for this particular SaaS provider and seeing that it isn't as straightforward as a key can give you all access or just a subset of that access. GitHub is another example. I'm sure many of you have created classic as well as fine-grained tokens. I think the name fine-grained isn't super accurate, actually. I think they're both fine-grained token types. With the classic tokens, you can choose which scopes that key has, but then it has access to all resources under that scope. So if you give it the ability to read a repository, it can read all of your repositories. Fine-grained, as they've defined it, you can still give that same scope of repo, read, but then you choose which resources, which repositories it can read from. So it's a little different. And I bring these up just to provide examples of how each SaaS provider is different. And that's not even talking about the cloud providers too, AWS, Azure, et cetera. That's even more complicated. But just looking at these SaaS providers, there's a lot of nuance in their API architecture. So when we're thinking about identifying the permissions associated with an API key, just by having that API key, right, this self-discovery idea, the first step, and there's two, is we need to figure out the key type. In many cases, like Open Weather, there's just one key type. So if we find a key, we know it has full access to the API. There's another scenario where it doesn't tell us what type of key it is, but there's some indication from the server of what type of key it is. This is an example of a server response headers from a GitHub request using a classic token. And they have this header X OAuth scopes. Now, if you use a fine-grained token, which is a different token type, that header is absent. So the absence of that header indicates to us the key type. And that happens not just in headers and other fields on API responses from different providers, but generally that's the idea. It's like, let's look at two different examples and try to infer which key type it is. And last, sometimes we can literally just query the API and in the response, infer the type. So in this case, we see that for SendGrid, there's a scopes endpoint. And if there is the presence of a billing scope, we know it's a billing key. And if not, we can do some logic to figure out, is it full access, billing, or restricted? So the first step is getting this key type, right? Again, we're trying to determine what the permissions are associated with the key. Because once we know the key type, now we can enumerate the permissions. In the instance where there's only one key type, like Open Weather, we just look at the docs. It can access all these endpoints. So we just kind of notate down which endpoints it can access, and now we know the permissions that it has. Another way we can do it if there isn't just one key type is we could query the API and just analyze the strings. In this case, it's pretty simple, a little more complicated than the first, but say there's a scopes or a permissions endpoint that the API has documented and exposed. We query it. We get this laundry list of all the scopes that it has, and then we have to make sense of it. And at least in the case of TruffleHog Analyze, this is a screenshot of TruffleHog Analyze at the bottom. We try to put it in a nice, neat table that is mirroring the GUI from the actual SaaS provider. So in this case, it should look similar as much as possible to how you would actually create the key to show what the access is there. So that's just involved, but we have to look through the documentation, do some translation of what the scopes are, and then create a nice, neat table. So that's also not that hard. Then it gets very, very difficult. Then we have to, for cases where there are multiple key types and we don't know based on just one endpoint like slash scopes what the permissions are, we have to do something called brute forcing. And what that means is for every single permission, we have to send a request to the server using that API key to check to see if we have that permission. Takes a lot of work just to build the infrastructure to do this, or the logic rather, not the infrastructure. So I'm going to give you an example. This is from an API key on GitHub, personal access token. In particular, one of the permissions that it has is read access to actions. So the process that we'd go through to like brute force, quote unquote, these permissions is we would go through the documentation, look up all of the action endpoints, find one. On the bottom left, you see I highlighted in red that says it requires read permissions. And then we have to send a request. And then based on the response of the request, we infer whether it has that permission or it doesn't. And then we repeat that 39 times for GitHub because there's 39 specific permissions. It's 127 times for Stripe. It is extremely time intensive to brute force permissions. I mean, I gotta say, it goes fast, right? You're just sending 39 or 120 requests. That goes fast. But being able to develop the logic to understand what endpoint do I need to query to determine whether this key has that permission, that takes a ton of time and a lot of just digging through docs. And when we think about, and this is more targeting TruffleHog Analyze, but when we think about brute forcing, we want to make sure there's proper guardrails. And so in general, we want one endpoint that we can query for every single permission. And we want that endpoint to not change state, and we want it to clearly and consistently give us a response that determines whether or not that permission is on that associated with that API key. And so some of the ways we're doing that is by prioritizing GET requests over any other HTTP method. We are looking for requests that return minimal data or no data if possible. If we have to use an HTTP method that implies state change, like delete or put, we're ensuring that they are malformed requests so that we're not actually changing data. And then we need to stay up to date on all of the specifications from that API provider because if something changes, we need to know. So that was just identifying the permissions. So we got whose key it is, what permissions are there, and then last, what resources can it access? And by resource, just to clarify what I mean, is this is some object that the API key can access. And further, I would say we're classifying it as something that might be valuable to a user or an attacker. It's not just anything that somebody could access with that API key, it's something valuable. So for the example of GitHub, it's a repository. For SendGrid or MailChimp, which are email marketing providers, it would be the domain that is verified and able to send valid, authentic emails from that provider. For SQL servers, it is a SQL statement. I'm sorry, a table in the SQL server. So in order to get these, it can be super easy. This is an example from SendGrid, I believe, where you just query for the domains. It tells you, great, super simple. And then we have our least favorite option of brute forcing. Sometimes it's not possible with NPM. As far as we understand, the API doesn't give you an endpoint to easily list all of the packages that that user can push to or update. So for that reason, you need to find out the total universe of packages that that person conceivably could have, and then you need to test them one by one. That's a lot of work and not super straightforward. So all this to say, this is the methodology. There's a ton of here. It's a lot of work. We created TruffleHog Analyze so that you don't have to do this one-off for every key that you want to analyze. The idea is that you can just use TruffleHog Analyze, and we are keeping everything up to date and adding more and more providers as we go. So what is it? It's a command line tool in open source. It's also part of an enterprise product, which I'll show in a second, that implements API key permission and resource self-discovery. And I would add to that ownership information as well. So let's look at a couple demos here. First would be GitHub. So this is an example of generating a classic GitHub token. I'm going to provide it three different permissions: repo, read. Uh, well, I missed those actually, but we gave it three permissions. So what we're going to do with TruffleHog Analyze is we're going to pass the key in, and then it's going to self-discover all this data just from the key. It was repo, read public key, and read SSH signing key. That's what it was. But also going to tell you who the user is, when it expires, what type of token it is, and then what it can access, in this case, the repositories. I have a second example for GitHub. Now, what you're going to look at is GitHub's code spaces, and just 10 seconds on that. Uh, Code spaces is a in-browser VS Code, basically, Visual Studio Code, associated with GitHub that you can edit your repositories and immediately push changes to it. So there's inherently some permissions in GitHub code spaces for users to be able to push data to it. So I'm going to go back to this here. So I went over. And if we look in our environment variables of a GitHub code space, there's actually a GitHub token. And I was kind of curious, like what permissions does this token have? I didn't create this token. GitHub auto created it. Like, but what is it giving it? What can it access? And after we run TruffleHog Analyze, we see that this token um, has quite a lot of permissions. We see it's for my account, this Truffle Joe account. It's a different type of token. It expires in 12 hours. It can only access one repository, which is good, but look at all these permissions it has. It has like read and write permissions, like write permissions on secrets. It can open pull requests, update content, create new issues. It can do a lot more than I expected it was able to do from this like in-browser code editor, basically. Um, so just another use case of TruffleHog Analyze if you just want to understand, like maybe you come across a token that's yours and you don't even know what it can do. This is an easy way to identify it without having to dig through documentation. Let's look at two more examples. Postgres. I honestly think this could be a standalone tool, just being able to easily analyze user permissions on SQL databases. But you start with a Postgres connection string. Similar to GitHub, you pass it in here into the terminal user interface. And then what it's going to do is determine what user it is, what privileges that user has overall, like on the entire server, what privileges they have against the database, and then more specifically within a particular database, what tables can it access and how much data is in that table. If the table has no data, then it's fine, but maybe it has a ton of data. And that's kind of a quick snapshot of information that responders might want to know when they're understanding the risk of a key. This is an example of an admin for that same SQL server. You can see it has a lot more privileges. It can create against both databases, so it has a bit more elevated permissions. And then also, it now can access this table called passwords in super secret database. And that's just to show that different levels of permissions for different users. Last here is SendGrid. So we covered that there's three different key types at the very beginning: full access, restricted access, billing access. I'm going to show an example of a restricted access key where we're adding a few different permissions. So in this case, we're adding mail send, marketing, we're adding some tracking, sender authentication, just a few different permissions. I'm going to go ahead and create that. I'm going to skip ahead a little bit. I'm going to pretend that I committed that key into this file. And then when we analyze it, and you can see this is another way in the terminal user interface to get to the right analyzer. You pass the key in. We are logging the request, and I'll get to that in a second, what that means. And here you can see it has mail send, marketing, sender authentication, tracking, read and write access, the exact same permissions that we gave it. Now we're going to use that same key, but change the permissions. And we're going to change it to a full access key. Well, I'm not sure why I went down here in the screenshot. Oh, I guess to show that it has those permissions. There we go. Yes. Okay. Now we'll change it to a full access key. We're going to run the same exact command again because we're using the same key. It's just been repermissioned. Once we run it, we see that it now has a lot more access, right? Before it only had maybe like 6 lines of scopes. Now it has a ton more. And that's just to indicate that this is the different output that you could see. Now, if you are a GitHub or not GitHub, TruffleHog Enterprise customer or interested in it, I just wanted to show briefly what this would look like in the application. This is an example of um, TruffleHog Analyze inside the actual application. You can see it's a bit clearer to see what the resources and permissions are associated with a particular key as well as the metadata. And it's in the same screen that you would imagine the data to be in if you're familiar with this for generally triaging a secret that's found. So what key types are we supporting? It's not everything, right? TruffleHog OG does 800 different key types that we can identify. Um, we're supporting just over 20 right now. And these are the most impactful 20 based on all of our data. We're going to be adding more and more and more to it. But this is where we're starting. And so right now, as of right now, you could run TruffleHog analyze and analyze any of these key types. So who is running it? It's the same team as TruffleHog. It is the same engineering team that we have on staff. It is also the same open source community that contributes very actively to it. I mentioned logging a second ago. So if you are responding to a exposed key, and let's say you want to run this tool, or maybe a bug bounty hunter ran this tool if that was in scope, you might want to have a log of what requests were sent. This is super basic. It's just date, method, path, and server response status, just to provide a little bit of extra information if it's needed. Is this a useful tool? I think so. We had a pretty cool example in our community Slack where somebody said somebody at their company leaked a Slack token. That person left. They didn't know whose key it was. They ran it. They figured out what Slack app it belonged to, and they're able to quickly remediate. And I think the last line there sums it up is it helps inform urgency. Again, it makes it easier to get this data, but it also helps you prioritize how to remediate and respond. In the wild, for me, this is an example of me using it. I reported a set of exposed keys to a HackerOne program. The response was, we already knew about those keys in the past, but they didn't rotate them, so they're still valid. And it was because the internal team, aka the developer that committed them, said it wasn't an issue. So I said, can I run a few API requests to see if it actually is an issue or not? And they said, sure. And I said, well, it seems to be an issue. And I provided them some details, which I won't disclose here. But they then changed this to the status of triage, which basically means this was a valid report. And there was no bounty. There's nothing glorious about this scenario, but I think it's more a proof of concept to say you can demonstrate impact, especially in the face of somebody trying to just cover their tracks and say it wasn't a big deal, there's no risk. You can actually say, wait a minute, let's revisit it. And not to say gotcha, but more to say this actually could have been a security issue. Let's just investigate a bit more. If you want to run TruffleHog Analyze, just make sure you have the latest version downloaded and run TruffleHog space Analyze. That will give you the terminal user interface, the TUI as it's called, where you can scroll down and click on a specific key, pass in the API key, and then analyze it. And don't forget, logging is also an option if needed. Sorry about that. Thank you all very much for attending. If you have any questions, I believe we have the chat open. And if not, happy to answer emails, or our community Slack is available, our community Discord as well. Always happy to take questions there as well. Thank you.